that.
All right. Let's start with preparing salts, right?
Mhm.
We have already understood that if you look at it, if you generally look at it, preparing salts are made from what? Acids plus bases, acids plus metals, and acids plus carbonates. Even though carbonates themselves are salts. So basically, carbonate themselves are actually salts. So basically, they all of them are going to produce salts,
Mhm.
right? Salts. Oh, now this is the kind of a mind map and overview for the topic. When we are preparing salt, there are a few methods. We discuss them. Methods of preparing salts. Generally, we say that preparation of salt can be divided into two major distinctions. Whether you are preparing a soluble salt or an insoluble salt. All right. If you're preparing a soluble salt, we have two methods. It's called method A. This is called method B. All right. What is method A? Method A involves soluble salt is prepared using insoluble reactant. Right. Soluble salt is prepared using insoluble reactant, and method B, it is soluble salt prepared using soluble reactant. If you look at this explanation, you will see that I'm only talking about one of the reactant because another reactant is always acid. So in method A, it is always acid plus insoluble reactant. Do you understand? And here acid plus soluble reactant. Do you understand?
Yeah.
Are you sure? Is this making sense to you? So when we talk about method A, this method involves making a salt using an acid and an insoluble substance. Acid and insoluble substance. Like how? Look at this. This involves acid plus metal reaction, acid plus insoluble base, and acid plus insoluble carbonates. We'll write about each of these in detail, don't worry. Something that is very important over here, whenever you're using method A, you have to keep in mind that insoluble reactant is always in excess, is always in excess. All right. So all three of these things, 1, 2, and 3, will all be in excess. insoluble reactants are always in excess. Now, why in excess? Why do are they, why do they need to be in excess? If you look at the apparatus itself, this is the acid. All right, you're going to add, let's say you're going to add a metal. The metal is going to gradually react, and this metal should be in excess. Why? So to make sure that all of the acid has reacted, that all of the acid has converted into salt and water. Do you understand? And then the excess reactant can be filtered out to give you a pure solution of salt. Did you understand this point? A question that is going to come to you in exam for sure, definitely. Why is the insoluble reactant kept in excess? So that all of the acid has reacted, to make sure that all of the acid has reacted. So the insoluble reactant can be filtered, leaving only salt solution. You understand this point? If it is not going to be in excess, if this reactant is not in excess, any of those insoluble reactants, if they are not in excess, what is going to happen? We will never get to know whether all of the acid has been converted into the solution, salt solution or not. If it is not in excess, then this solution over here, this solution over here is going to be what? It's going to have, we are not sure if it has acid or not, acid and salt and water. You understand? In order to make sure that all of the acid has finished, we use excess of insoluble reactant. Do you get it? So that all of the acid is going to be reacted, and there will be no more acid anymore. Only excess of insoluble reactant will be there, and the salt solution is there. So we can filter this solution. We can remove the insoluble reactant that is there. We will be left with only salt and water, and that salt and water, this solution of salt can be crystallized to make pure salts, to get the pure salt, to make the pure salt. Do you understand this point?
Yeah.
So after that, what takes place after this? What are we doing? So in method 1, we take insoluble reactant, we react that with an acid, then what do? We filter the mixture to remove the residue. What is the residue? Residue is the insoluble reactant. All the acid has reacted now. There's no more acid anymore. All right, so it can be removed. And number one, number two, collect the salt solution as the filtrate. You get it? Now this filtrate is the salt solution. This salt solution, this salt solution is crystallized. Crystallized. How is this crystallized? Number one, made into a concentrate. Number two, crystallized. Number three, filtered and dried. And you are going to have a salt crystal. You understand this as this point?
Yes.
You see how this method worked, right? This is the salt preparation method A. We're going to write about method A in detail as well. What are the reactions that generally take place? Similarly, we have method B. Method B leads to the same salt solution. But the important point about method B is that method B is called titration. One of the most important things that we would have to do. Titration. This is called titration, in which both of them are soluble. It means acids are always soluble. We know it, they are always aqueous. Plus alkalis or or soluble carbonates like sodium carbonate or potassium carbonate, right? So they are going to be the ones that are used. Now the important point, the problem. What is the problem? The problem is that in insoluble ones, in the insoluble ones, we were able to easily do what? In the insoluble ones, we were easily able to get to know that if all of the acid has reacted, and what is left in the beaker after the reaction is the pure salt solution. But here, both of them are soluble. How are we going to get to know? Hmm? How alkalis over here means metal hydroxides,
Mm-hmm.
right? How are we going to get to know? We use indicators. What do? We use indicators because in this reaction, no residue is seen, right? Both of them are soluble. You're not going to see anything. You're not going to know whether if there is any acid still left or not. If all of the acid has reacted or still is there's any left. So what do? We use indicators. So in titration, indicators are used to tell exactly how much acid or alkali is required to neutralize. All right. So how does this work? It works in a manner that When you are reacting, so there are going to be three things in the reaction: acid. So there is acid plus alkali and the indicator. The moment this alkali is going to be neutralized or the acid is neutralized, this indicator is going to change the color. All right, this is one of the methods. We'll go into it. I just want you to understand at the moment. And the third one and the last one, making insoluble salts. The method that we use to make insoluble salts is called precipitation method. Precipitation method. In precipitation method, it's not something that is very difficult to understand. It just, by precipitation methods we make insoluble salts. We already know the reactants, right? We know that certain types of carbonates are insoluble. Let's so we know certain types of carbonates, certain types of sulfates are insoluble, like calcium and barium sulfates are insoluble. So if you're going to be reacting calcium with sulfuric acid, you're going to get a precipitate. You're going to get a precipitate, calcium sulfate. This is solid because this is insoluble. You understand? So you're going to see a precipitate, a
Yeah.
cloud forming inside the test tube. Is this clear?
Yeah.
I'm writing this down. You need to write it down, or you're going to write it later.
I'll write it later.
All right.
I wrote some, but we can just move ahead. I
Right.
have to go, so we can just finish this off.
Right. Few points that we would have to understand in method A. When we were talking about method A. Method A was what? Method A was making soluble salts, but with insoluble reactant, right? So it's going to be acid plus insoluble base. Example of that could be insoluble base example, and we have to make sure that we write excess to that, excess of insoluble base, right? We can have H2SO4 plus copper oxide, which is soluble. This is aqueous. You're going to get copper sulfate, which is a soluble salt, aqueous, plus H2O liquid, right? Then we discussed about acid plus metal. Very easy. You need to make sure that you remember plus magnesium is going to give you magnesium sulfate plus water, sorry, plus hydrogen gas. So this is aqueous, this is solid, this is aqueous because this is soluble sulfate, and this is gas. And then we have carbonates. We can have HCl plus MgCO3. We're going to have, we know what, we know these metals, they actually replace the hydrogen in the acid, right? So this is going to be magnesium chloride plus carbon dioxide plus water. This is gas, this is liquid, and MgCl is an aqueous solution because this is soluble, and we know carbonates are insoluble, so it's going to be solid, and this is going to be aqueous. This is making sense? Hmm? Plus
Yeah.
carbonates. All of them are going to be excess, 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 right? Needs to be aqueous, excess, so that so all of the acid can react, and then we can remove one of the reactant, and we are going to be left with this only, or this only. All right. So what is done then? The solution. So this is going to be, let's take an example of copper, zinc sulfate. Zinc sulfate. We are doing this by zinc plus sulfate to give you zinc sulfate plus hydrogen gas. All right. This is solid. This is going to be aqueous. This is aqueous. This is gas. So what are we going to do? Number one, add zinc powder to excess of it. Zinc powder to dilute sulfuric acid. Right. Once
Mm.
that has been done, after some time, we're going to filter the solution. All right, whatever is there, filter the mixture, or let's rather write filter the mixture, because filter the mixture is more appropriate word. Can you tell why? Because it was a physical combination, not a chemical combination, so we can still see zinc over there, and the solution is there, still there. So filter the mixture. Zinc powder that we added becomes the residue, right? And the salt solution and zinc sulfate solution becomes the filtrate. You get it? Now the third process, the filtrate is heated to concentrate the salt, right? So this filtrate is going to be put, it will be placed on a tripod stand with the wire gauze. This is evaporating dish with a burner. So this is going to be done what? This solution, this is a zinc sulfate solution. This is evaporated so that it becomes, to concentrate the salt solution. To concentrate the salt, solution. What does that mean? The water is going to evaporate and you will be left with more molecules of sulfate than the zinc sulfate than the water or the solvent, right? So solute becomes more. Then what are we going to do? We are going to test for saturation. Test for saturation. How are we going to do that? We're going to, from time to time, dip a clean glass rod into the heated filtrate. The filtrate that is being heated, we have to dip this clean glass rod from time to time. But because this is cold, once the solution attaches to the glass rod, the water evaporates and crystals form. You understand? If the filtrate if the filtrate has saturated, crystals will form on the rod. Is it making sense? So you are going to dip the glass rod time to time, and when if you bring it out, you will see that there are crystals that are forming on the glass rod. If this sign is only once you dip and you bring it out, you're going to see after a few seconds some crystals form on the glass rod, and this represents that the solution, the filtrate, has become saturated enough for it to go into this such crystallization process. So this is all of what we are writing right now is actually salt preparation through crystallization, right? You can also get salt by evaporating. You can evaporate all of the solution. You can evaporate the solution and you will be left with a powdered form of zinc sulfate salt, but we are trying to get the crystals, right?
Mhm.
So the fifth point over here should be the filtrate is saturated when the filtrate is saturated, it is leave it to or leave it leave it to cool and crystallize. All right. So they are going to be left to cool and crystallize. Like this, there's going to be some of water, but most of them are going to be the crystals that have formed. Right. This crystal can be filtered out, you can filter the crystal, and you can dry them with the paper. This is it. All right. Is it making sense? Did you understand?